theory lectures. And if there are some things which will require coding, writing the things and executing them out, so I'll leave it, you can explore them on your own, and you can always approach me in case you have any doubt. So in today's session also, we'll look at a few graphs, we'll look at some of the problems which you might face with Igraph and how to resolve them. We'll also have a quick activity in the today's class. Just give me a second, I'll share my screen. Is my screen visible? Can someone confirm?
Yes, ma'am.
Okay. So most of the time for any of these iGraph functions, you can look up the online manual. So what all you need to do is just type Graph Python on Google and go to the website, go to documentation. There are two things here. So first is this tutorial right here, and another is a reference manual. So tutorial, I would say, is completely for the newbies. So even if you want to execute all these steps, you can run them one by one and see if we have missed out any of these in our lectures, and if something is very different here. So it's mostly about creating a graph, looking at the edge list of a graph, deleting edges, creating tree graphs, setting and retrieving attributes. We have not done the structural properties of the graphs yet, so we'll soon start with this one, right? And querying your vertices and edges for specific attributes, so on and so forth. Once you have done this, so you can always go to this reference manual here. So it consists of all the functions which you find in iGraph. So if you see here, so currently I'm in the package Igraph. So this one here tells you all the functions of this class Igraph here. These ones over here, get, include, read, load. But most of the times the functions which we are going to use, you'll find them either in this class graph or in the class graph base. Let me just open it. So this is your class graph. These are all the functions you have available here. So let's talk about few ones which are easy to understand. So like cut vertices is here. So you can look at all the cut vertices in a particular graph. Then you have discussed the shortest path algorithm implemented here, adding vertices and edges, converting a graph to its undirected form, deleting edges, looking at in degrees and out degrees. We are yet to talk about that. uh, Looking at the components of a graph. So if a graph is disconnected, how do you find out its connected components? So you will find some familiar functions here, some might not be very familiar. So these all, they are community detection algorithms. We'll talk in one of the later lectures. These are different layout algorithms for seeing your graphs. Uh, some bipartite functions, so on and so forth. And this is the another class here. So some functions might be similar also. So here you can find these functions: read GML, write GML, and then uh, all ST cuts, ST min cuts. If you have heard about min cut max flow algorithms, articulation vertices, so on and so forth. So clicks are complete graphs. So determining clicks in a network, so on and so forth. And again, it again has all those community detection algorithms. So when you have some free time, just skim through these functions, see if you are able to implement them or not, so on and so forth. So coming back to where we were in the yesterday's class, we were trying to read a retweet network. So we have read an edge list from this file rt-retweet.mtx. So let's just quickly see how this looks like. We have read it in a data frame. uh, so I made a small mistake here. Let me set here header equals to none, so it doesn't take anything as a header. So this is how your data frame looks like. Let me also show the actual file to you. Are you all familiar with pandas data frame in Python? Even if not, we will be covering some basic functions here and there. So one thing you can always keep in mind that for doing this coding, crunching graphs and playing around with all these pandas data frame, you need not be an expert. Even I, most of the times what I do is if I get confused somewhere, you just Google it and you will find a small code snippet on Stack Overflow. And if you can understand that, that should enough and that should do. Okay, so let's look at this file here. So this is our file. My first row here has 5 columns and the second one has 3 columns, and after that every row has 2 columns or 2 values. So each one is an edge here. When I imported it as a data frame, what happened? So since my first column was having, and it also has a space somewhere here. So if you look at it, probably there is some space here, right? So it's actually taking 6 columns. 5 are these ones which are mentioned over here, and a sixth one it's making it an ends. So you can see that overall, and for the remaining rows also it extends the number of columns. So I have more columns than what I need. So what I want as my data frame is are only these pairs, the UV pairs. So 6 1, 8 1, 54 1. So what I want to do is just check out these first 2 initial rows and also check out these 4 columns. Once I do that, I get my data frame intact, and then we can make the graph with the help of that. So I'm first going to drop out these columns. So I don't want my column numbers 2, 3, 4 and 5. So I'm just going to take a list here which has my column numbers written here, and I'll drop them from my data frame. Some additional attributes which it requires. So in place actually tells me whether you want to make a change to the same data frame or not. So if I do not give here the value of in place, it will actually return a new data frame which I'll need to collect in a variable on the left hand side. So I'm dropping these columns, and then let's look back at the value of EL. So you can see here, so now we have these 2 columns only, 0 and 1. Next, what I'm going to do is we have to check off these first 2 rows. Even I'm not sure what is the exact command for that, so let's just look it up. Yeah, so see, we have a simple command here. We can use this one. Just copy pasting that thing here. And since I have already done this, I'm going to comment this one here. And again look back at the value of EL. So I got this. Okay, did a small mistake here. So I wanted to remove only 2 rows. Change it to 2. So I get here all the rows which were relevant to me. Okay. Next, I'm going to give its header some value. So, I want to give these columns some names. So, what is happening here is, so it's a Twitter network, and the rows here tells me about the tweets. So what is the first person here? First person is the person who is tweeting, and second person is the person whose tweet is being tweeted. So actually the first person here should be a follower of the second person to retweet his tweet. So I'll say that my first column is follower and my second column is following. Now what I'm going to do is when I create a network using this data frame in its current form. So if I create a network, so what will happen is I'll have edges running from 6 to 1, 8 to 1, 54 to 1, but I don't want edges like that. So I don't want my edges to run from follower to followee, because this is followee's data which is coming to follower. I can reverse their direction. So most of the times when in future you will implement an information diffusion model, so we mostly want to diffuse the edges should be in the direction in which the information is diffusing. So information is diffusing from followee to follower, not from follower to followee. So we might consider swapping these columns here. So I'm going to swap both of these columns here. I'm going to do a reindexing. In reindexing, I can rewrite the names of the columns here in the order I want it. So I want a followee first and then a follower. Again, look at the value of EL. So now my data frame looks perfect and I can use it to create a network. Now what my question was yesterday, we actually made a network, and what we saw in the network, we didn't have any edge like 1 to 6 or 1 to 8 or 1 to 54. So did anybody think about what was going wrong there? So what are the indices of nodes in an Igraph object? So whenever I create a graph, the index of the node starts from 1. So the index of the first node is 0. I'm sorry, not 1, 0. The index of the first node is 0. Then for the second one, it is 1. For the third one, it is 2, so on and so forth. Right? But if you look at this data frame here, the naming of the nodes, it doesn't start from 0. It starts from 1, and then maybe some values are missing in between too. I am not sure. So maybe there is no 4 anywhere. So 1 is there, 2 is there. So I'm not sure whether all the consecutive numbers appear here or not. So that is a problem. So when iGraph tries to convert it in the form of a network, what happens is it is actually looking for a vertex with a number 0, and from 0 onwards to 89, and no number should be missing in between, because the nodes indices are consecutive in iGraph object. In this case, it's not so. I do not have a vertex named 0. So what iGraph will do, so when I create a graph from this object, it will implicitly, it will renumber all these nodes from 0 to whatever is the desired number. So let's quickly do that and see. So we can always in the graph creation function, we can create a graph from tuples. I'm going to convert each of the row here in a tuple here. And then we pass it to a graph creation function. So I'm going to create a graph here, and my graph is a, let's say, a retweet graph.
Ma'am, you have an extra bar, ma'am.
Where?
Here, after tuple x, you have another extra one,
Just a
ma'am.
minute.
Here.
I'm sorry. And I want this network to be directed. So with any graph creation object, whenever, whether you are creating it from a tuple or you are creating it from a adjacency list or adjacency matrix, you'll always have this parameter called directed, which you can set to true or false. I think by default it's true, but confirm it once. So this is my graph. So I have not yet imported igraph. Let me just look at this graph here. So this graph is a directed graph. It has 96 nodes and 117 edges. Let's look at these edges quickly. So if I look at the edges here, I find completely different edges, right? So these are from 0, 1, 0, 2, 0, 3, 0, 4, which were not there in my original data frame. So what has happened? Some renumbering has happened. 1 has changed into 0, or maybe 6 has changed into 5. So I don't know what has changed into what. And I need to keep a track of what is happening. So you will see here when I printed the summary of this graph here, the graph here appears with an extra attribute which is called name. So what is happening here? This name attribute, it carries my original names of the vertices which actually come from this data frame. So let me actually look at this. So if I type here, I want the value of this attribute name. So see, I got a list here and it tells me the name of every vertex. So what is happening? 1 has become 0. So the node which is having an index 0 is nothing but which was 1 in our data set. If I have a node 1, so 1 is actually 6. Right? So these numbers, they are coming from my data set or the data frame, and these have been labeled from 0 to whatever was the maximum number over here. So that is what happens. So you will face this thing with iGraph. It won't happen if you are working with another package which is NetworkX. So assume that I've made some graph in NetworkX, which is another package which had certain vertices numbered any integer values, not necessarily starting from 0 and not necessarily consecutive, and then you imported that as a GML file in your, exported that as a GML file in your system, and you open that GML here, you won't see the same node numbers. Things would have changed in iGraph. Okay, next. I want to plot this graph. So what you can do is you can actually plot this graph, and while plotting this, you can set the vertex labels to be these names here. I can go ahead and do a igraph.plot. I'm going to plot this graph where vertex label is this thing here. So now in this graph, the labels which you are looking will be based on your this thing here, based on your data frame. Another thing which you would have seen is when it has this name attribute, all these values are converted into a string type. So when we were looking at these values of name, all of them were coming in between quotes, so they have been changed to a string type. So this is how you can work with a data set taken from an online source. What we are going to do now is we are going to create a data set of our own, and then we are going to see. So assume that you are conducting some real time survey to study the friendship network of a class, and you want to make sense out of that network. So we are going to create a real world network just now in between all of us, and then we'll try to visualize it. And slowly over time now we will see that what in that graph is important and what can be studied. So if you have any questions, ask me. Meanwhile, I'll just look up where the document is. Sorry. Okay, so I'm sending you a link in the chat box. Just open this link. So I've slightly populated this sheet beforehand. I should come to this sheet here. So I see three of you are already here. We have two more people. Okay. So what you're supposed to do here is it's just a small activity. Each of you have to imagines a few fictitious characters or some imaginary characters. So these are some six which I just like that imagine. So enter some five characters here and some cooked up genders, hobbies, their age and remarks here. So that is the first thing you have to do. You can give an ID to each of these characters, and again that ID need not be consecutive, but ensure that you do not have any duplicate entries in this first column called ID here. Then we have this second sheet here. What we are doing in this second sheet is we are creating a Twitter like followership network. So the first one is an ID here. So this is my own ID. So whatever is there in ID here in the sheet one sits exactly the same way here. And then each of these person is going to tell which are their friends. So the person with ID 2 here says that person with IDs 5, 8 and 6 are my friend, or I would like to be friends with these three people, or I follow these three people, so on and so forth. So this is the same for the person having ID 5. So you enter their IDs here, and at a max you can type up to 5 IDs, and a person might not like a lot of people, he might end up entering only one ID if he is not very friendly. So you can start editing it. Each of you can add some 4 or 5 characters here, fill all these entries, and once you are done with filling the first sheet here, you can go to the sheet 2 and enter the IDs of the characters you would want to be friends of, and ensure that you are not biased towards your own characters. So go ahead and do this, and then we'll convert it in the form of a graph. If instructions are not clear, you can ask me again. I want each of you to be editing this sheet. I'll stop sharing my screen. Make sure that you populate this sheet. Okay, mom, she's done. I'm also done. Satvik is done.
I'm also done.
Okay, so everyone done or someone remaining? Gupta's done, Ali's done, Harshit done, Vamshi done, Satvik done, Navneet done. Okay, so now what I'm going to do is I'm having these. I'm audible, right? Yes. So I'm having these two sheets here. Sheet one, which has the characters and different attributes, and the sheet two here has a friendship network. So what kind of a representation is this? What kind of a graph representation this is? It's an adjacency list representation, right? So this vertex here tells me that it is 2. 2 is pointing to 5, 78 and 90. 5 is pointing to 6, 8, 10, 31 and 68. So we have this kind of a adjacency list representation. Now one problem we run here into it. So we have discussed yesterday about how in Igraph you can represent adjacency list, and the format was an LGL format, which was quite weird, and you'll have to do multiple things with the sheet to bring it into that format. So rather what I'm going to do is here one function of network X comes in handy. So there are certain functions which you'll find are good in one package. Sometimes you might find another function which works with another package, but not with your current one. So you can here and there take a shift between the packages to explore only those particular functions. So as of now, I'm just going to download this file here as a CSV on my system. I'm going to open it in Notepad. So I'm going to feed it in my network X algorithm, but that algorithm, it requires something. So I need to do a bit small edits here. I don't want a header. In addition, I'll remove all these extra commas which appeared because there were no entries there. You can also write a small piece of code to do it. So in this case, it's a small file. We can do it manually, but assume that you are conducting this activity for 500 or 600 people or over all the people in your university. It will be difficult to do it manually. Okay, so I have this file here. So while we're doing that activity, actually I wrote the code here. So this is another package which is network X. So I've imported it as NX. So this package has a function which is called read underscore adjacency list, which will read your graph here, and it will create a directed graph. And a delimiter is comma. So you need to like in pandas data frame you give a separator, here you give a delimiter. For my first file, so when you read this, your graph is created. So let me just execute only this much as of now. So my graph is, okay, it ran into some error. So there is no such file. Let me look at it. Okay, I'm going to rename it here. So your graph is created, and you can actually look at that graph here. Yeah. Uh, so you can see all the edges in the graph here. So you see here, when you imported this in network X, you got all the names intact. So 2 remains 2, 420 remains 422, 420. But if you do it in iGraph, things will label them from one thing to another. So that's why sometimes importing it in network X is a good option. Next, I want everything here to have an attribute. So as we see in this sheet, every character has these attributes: char name, genders, hobbies. So I've slightly changed this that char underscore name to char name. I'll tell you the reason in a while. So what I'm going to do, I'm going to export this graph in GML format. So when you export a graph in GML format, as I told you, its attributes are also stored with their names. So one issue there is your attribute names, they should not have any underscore or any spaces with them. If that is the case, it won't be able to save it and it will throw an error. I'm going to download this sheet here as well. And again rename it, let's say, to attr.csv. So coming back here, I have created my network. Next, what I'm doing is I'm opening this attr.csv again in a pandas data frame. You can figure out this code again. So I'm setting these attributes in network X as of now. I don't need all these things here. Right, so let me do only this much here. Actually nothing. So let me first just yes. So here this is imported. Here are all the attributes. Next, I'm going to set all these attributes in your node attributes. So these are two commands which you use in network X. You can use a data frame directly to give all these attributes to your nodes. And what happened? Whatever is your ID field here, that is set as the index of the node. Okay, one problem you will run into there is, so this ID, its data type I'm not sure of. So you might need to convert this ID into an int type of data type. Let me just execute it and see. Okay, so I ran into two problems here. It says that data frame index must be unique. So is it that some of the index is getting repeated? Do we have a repeated index? Can someone quickly check in the file if we have any repeated index here?
Ma'am, 8 is repeating.
8 is repeating. Once you just remove this 8 and do these steps again here, so what will you get? You will get a graph here, right, with these attributes which are listed in these data frame here. And then you can export this data in a file which is friends underscore nw.gml, and then you can again open this GML in your iGraph and work as you want it. So what I'm going to do here is I'll generate this GML file. I'll email it to each of you. So open that GML file using iGraph. So forget about this network X stuff if you didn't totally get it. So I just wanted to tell you about this one function here which iGraph doesn't support very well. So just look at that GML file, open it in Igraph, and then see what are your node index, and do you again have a new attribute name? Because here again, if you look at the indices of the node, so the indices are going to be 2, 5, 6, 8, so on and so forth. So node starting from 0, 1, 2, 3, so on and so forth. So what does your Igraph do in that case? So check that out. That is the first thing. Second thing, just look at that network, visualize that network, assume that it is a Twitter network, and then think about the things you can do on such a network. So if I give you such a network on, let's say, our university, where every node is a person and everybody is telling you he follows which other people, what can you do with such data, and what would you want to study in such a graph? So just think about it and be ready for these answers. We'll take these questions one by one and start addressing them from the next class onwards. So tomorrow's class is reserved for project, not tomorrow, day after tomorrow's class is reserved for your project discussions with each other, and we'll continue with this on the coming Tuesday. The class is over. Okay, Ali, what are you asking is about adjacency list. What is the question?
No, ma'am, that was way before.
Okay, that was before. Okay. Okay, so if you have no doubts, you can leave. If you have any doubt, you can stay back and ask me. I'll send this DML file to all of you.